Hello, trig students, and welcome to a quick review of the law of sines. We're going to go over the three different cases that you can encounter when working with the law of sines. Of course, the basic theorem is right here. Sine of A over little a, sine of B over little b, and sine of C over little c are all equal to each other. Now, in practical terms, you're only going to use two out of the three of these ratios at any one time. And when you do, there's several different things that can happen. So let's go over those right away. And when you get your tests from me, you'll probably already have something filled in like this. All you have to do is fill in whatever else is appropriate. Now, when using the law of sines, you've got to start with a known ratio. So that known ratio is going to be this one right here, where we have an angle and opposite side pair. So I'll have sine of 20 degrees over 4 equals sine of, well, since I want to solve for angle C, I'm going to include this one, sine C over 6. Let's multiply both sides by 6. 6 sine of 20 degrees over 4 equals sine of C. Now, you don't necessarily have to write down the decimal value here, but it might be convenient just to be able to look at it. So let's clear out some of this stuff here. And you can follow along with my keystrokes by using the key press history down below. Start with 6 sine of 20. Make sure your calculator is in degree mode. You can tell the mode of your calculator by looking at the screen up at the top. Divided by 4. So that's 0.5130. And then I'm going to need to solve for sine from there. This is 0.5130, continues on forever. To solve for sine, solve for C, I would need to take the inverse sine on both sides. The inverse sine of the sine, that's going to cancel. So I'll just get C, and C is going to be the sine inverse of 0.5130, etc. Now, what I would suggest is that you use your calculator's features to try and keep track of as many digits as possible when working with these problems. So for us, in this example, it would mean taking the inverse of our previous answer. So hit the second key, then the sine key to take the sine inverse, and then second key of the opposite key, which fills in answer. So I'm taking the inverse sine of that previous number there. And I get about 30.87 if we're rounding that off to the nearest hundredth, which is typically what I'll ask you to do. So 30.87 is one possibility. But keep in mind, there's actually two possibilities. So I'm going to store this value in X. Store in X, just to keep it handy. And in this particular example, I can find another possible triangle if I take 180 minus X and get that other angle. So in this case, 149.13. Now let's take a look at some of the geometry to try and understand why I'm doing that. So looking at the top half of unit circle, we calculated that the sine of our angle was 0.5130. The sine is your y coordinate, so 0.5130. And when I took the inverse sine, I found out that this is about a 30.87 degree angle. But there's also a point in the second quadrant that shares that similar property, that it has the same y coordinate. So this angle is also 30.87 degrees from the horizontal. But if I'm trying to measure that angle from the positive x-axis, it's going to be this much. It's going to be 180 minus that little bit, which is our second angle here. So you have to look for both of those. Now, can both of those form a triangle? Well, let's put them in and find out. So the first one was 30.87. And since the angles in a triangle have to sum up to 180, we've got room for another angle here, which is angle A. How about down here? This one's 149.13. Do we have room for another angle here? Well, if you add that up, that's 169.13. So by subtracting from 180, yeah, you've got room for another triangle. So this is one of those cases where you get two triangles. Not everything's going to work out like that, but in this case it does. That second angle here would be 10.87 degrees. We just get that by subtracting these other two from 100. And likewise, this one would be 129.13 degrees. The only thing left now is to solve for A in both triangles. So let's do that. Now the calculations are going to be pretty identical for each of these. So we've got, say for the first triangle, it's going to be sine of 20 over 4 equals sine of 129.13 over A. If I cross multiply, I get A times the sine of 20 equals 4 times the sine of 129.13. Dividing both sides by sine of 20, that gives me A. And let's figure out exactly what A is in this particular case. So let's see. Let me clear out some stuff here. And I had 4 sine of 129.13. A lot of times I don't like to use rounded numbers, but since it's our last of a series of calculations and we haven't used any rounded numbers up till now, we should be okay. You can be a little bit more careful and store some of these intermediate values as you move along. Divided by sine of 20. And there you go, about 9.07. So approximately 9.07 for here. We're going to play the same game for triangle 2. Again, I'm going to start with sine of 20 over sine of 4, simply because these were exact numbers. That's already given. By using exact numbers, I'm trying to limit the amount of rounding error that I have. This time I'm going to compare this to sine of 10.7 over A, 10.87. The rest of it's going to look identical to what we have over here. It's going to be A times sine of 20 equals 4 times the sine of 10.87. Divide both sides by sine of 20, 4 sine of 10.87 over sine of 20. Let's calculate that on our calculator and try and be a little bit clever about that. So rather than typing in this expression from scratch, I'm going to hit the second key, then the enter key to pull up my previous calculation. So second, enter, and just go back and change the one number that I need to change, which is this one. I need to make it 10.87. So I'll hit the delete key once to delete one of those characters, and then just type over the rest of it, 10.87. And there we go. Round it off to the nearest hundredth. That's going to be about 2.21. So let's put those numbers back into our table then, the rest of it. So I had 9.07 here and 2.21 here. So yay, looking good on that. We can do a little bit more in terms of checking our work. One of the things that you can pick up by looking at the law of sines is that all these ratios have to be in proportion. And the net effect is that it means that the biggest angle is going to be opposite the longest side. And the smallest angle is going to be opposite the shortest side. And then the middle and middle pair up as well. So does that happen here? Well, you have the largest angle opposite the longest side and the smallest angle opposite the shortest side. And again, middle and middle. So it all works out pretty nicely. Same thing holds sway down here. Largest, longest, smallest, shortest, middle, and middle. Okay, looking good on that one. Let's try another one. So this one, which I'll set up over here. And let me copy down another triangle here, triangle 1, triangle 2. I'll always put both of these on your test, even if you don't use one. So don't think necessarily that because you've got it here for both of them that there's necessarily two solutions. There could be two solutions, no solution, or zero solution. As before, we got to start out with a known angle and known ratio. So there's known angle and side pair. Not much choice in this one. Sine of 50 over 2 equals sine of A over 3. Cross multiply. 3/2 times sine of 50 equals sine of A. And let's get a numerical value for this. So that's going to be 1.5, which is our 3/2, sine of 50. So 1.149 equals sine of A. And if you're paying close attention, you might see a problem. If you're not, that's okay. Let's try and take the inverse sine on that and solve for A. So we'll take the inverse sine on both sides. So A would equal the inverse sine of 1.149. Let's bang that out in our calculators. Second sine, second answer. And uh-oh, something's wrong. And the something that's wrong is that you're trying to find place on the unit circle where you have a y coordinate of 1.14. But that's not going to happen. The unit circle only goes up to a height of 1. So you're not going to find any angle whose y coordinate is bigger than 1. Just not. Another way to think of it is that the domain of the sine inverse of x is -1 is less than or equal to x less than or equal to 1. So anything outside of that is going to give you an error. For our last example, let's take a look at this one. So again, we'll start out with a known angle and opposite side pair. That'll be this one. Sine of 58 over 3 equals sine of A over 2, or 2 sine of 58 over 3 equals sine of A. Let's figure out what 2/3 of sine of 58 is. So I'll clear out this stuff. 2 sine of 58. Make sure you hit that right parenthesis divided by 3. So about 0.5654, we'll call it. 5654 equals sine of A. And if I take the inverse sine, wrong one. Inverse sine of my previous answer, then I get about 34.43 degrees. So that's one possibility. Let me store that answer in X. And then let's look for the other possible answer. That other possible answer is going to be 180 degrees. Well, it's going to be on the other side of our 90-degree line from that. So taking a look at this graphically, we had that sine was about 0.5654. So that gave us an angle about here. There's another angle over here. Let's find both of those angles. You don't have to draw these things. You can just work with the calculations. That's fine. So this one was, what was it, 34 point, oops, sorry. So here's our unit circle again. We had one possibility at 34 and change. And then the other possibility is going to be on the other side of the circle. Or was it? It was 34.43, we'll call it. 34.43. Then 180 minus that previous answer, second answer, gives you 145.57. So you get the same angle twice. It's just that the second time, if we measure from the positive x-axis, that's here, that adds on to be 134.57 degree angle. So we've got two possibilities, either a 34.43 degree angle or 147, how about 145.57 degree angle. And if you can hear the commotion up above, that's my dog Ozzy. He says hi and wishes you good luck with this problem. Mention Ozzy on your test for an extra credit point. Okay, let's take a look at these. So 34.43, that fits in nicely in this one, 34.43. And let's see here. So it's going to be 180 minus 58 minus x, which we stored earlier. So we're left with about 87.57 degrees. All right, so let's make that bigger. 87.57 degrees for a total of 180. But how about over here? If we try and put in that other angle, 145.57, 145.57, well, those two angles by themselves are over 200 degrees. So it's 203.57. That's not going to form a triangle in the geometry that we're studying. So there's only one solution, and it's this one down here. So let's stick with this and finish solving this triangle. We need to find side C. So I'm going to go back to what I was given to start with. That way I don't have to work with any rounded numbers. And that's going to be sine of 58 over 3 equals sine of 87.57 over C. Multiply both sides by C, sine of 58 equals 3 sine of 87.57. And then divide by sine of 58, C equals 3 sine of 87.57 over sine of 58. Let's calculate that, and then we should be done. Now, I will note that I've got that 87.57 degree angle here already. So when I'm ready for it, I'll just take the sine of the previous answer. So it's going to look like this. 3 sine of my previous answer, second, and then the opposite key. Close it off with the right parenthesis and divide by sine of 58. And bam, there you go. 3.53. 3.53. Let's look at it and make sure that it at least makes sense. Biggest angle, longest side, smallest angle, shortest side, middle, and middle. It works. Okay, I hope this helps you keep track of the 3 different cases and why we have 3 different cases. You always need to look for that second triangle. Even if it's not there, you need to look for it. I definitely look for one with 2 solutions on the test, but what else happens beyond that? You just have to work and see. All right, good luck.